Hello everyone, we are back for another episode of our video lecture for Grade 9 Science. Again, I am Sir Roy, and our topic for today is all about chemical bonding. The most essential learning competency that will be covered for this lesson is recognize the different types of compounds, ionic or covalent, based on their properties such as melting point, hardness, polarity, and electrical and thermal conductivity. The world around us is composed almost entirely of compounds and mixtures of compounds. On Earth, we could see rocks anywhere, trees, usually in the forest, cars on the road, and even us, human beings, are all complex mixtures of chemical compounds in which different kinds of atom are bound together. Now I want you to look at this illustration of a graphite. A graphite is a soft, slippery material which is used in pencils. On the other hand, this one is an illustration of a diamond, which is one of the hardest materials known, valuable both as gemstone and in industrial cutting tools. The question is, why do these materials, both composed of solely of carbon atoms, have such different properties? The answer lies in different ways in which the carbon atoms are bound to each other in these substances. The manner in which the atoms are bound together has a profound effect on the chemical and the physical properties of substances. Now let us proceed to our main topic, which is all about the chemical bond. It is defined as a force that holds group of two or more atoms together and makes them function as a unit. Look at this particular example, which is water, or the water molecule, which has a chemical formula of H2O. You would notice that the water molecule is consists of two atoms of hydrogen, which is bonded to a single atom of oxygen. The line that connects the hydrogen atoms to the oxygen is what we know as the chemical bond. To represent it further, we can look at this particular illustration. You would see that the oxygen atom holds the two hydrogen atom in place. So that particular connection between them is what we call as the chemical bond. Now, there are two basic types of chemical bond. It could either be covalent bond or what we call as the ionic bond. Let us discuss what is the difference between these two. Now, in covalent bonding or covalent bonds, the electron are being shared between the atoms. Meaning to say if there are two atoms that forms a compound, the electrons are being shared between these two. On the other hand, when we talk about or when we speak of ionic bonds, electrons are being transferred from one atom to another atom. To discuss it further, what is an ionic bond? An ionic bond is the force of attraction that holds together positive and negative ions. When we speak of ions, it means atoms that possess electrical charge. Now, it forms when atoms of metallic element give up electrons or transfer electrons to another atoms of a non-metallic element. As a clue for ionic bond, it only occurs between an interaction between a metal and a non-metallic element. Look at this illustration of an example of an ionic compound. This is what we call as the sodium chloride or also known as the salt. It is consists of the sodium and chlorine element. The sodium element is a metal. On the other hand, chlorine is a non-metal. Combining these two particular elements will form an ionic compound. And it involves a transfer of electrons from sodium towards chlorine to attain a more stable state. So here are the examples of ionic compound. The first one is what we call as the sodium chloride. It is being used for food preparation, manufacture of chlorine and sodium hydroxide. Another example is the so-called cobalt chloride. It is known as the silica gel, which absorbs water. Another one, we have here the potassium iodide. It is a component of iodine supplement in iodized salt. Another the one we have here is silver nitrate, which is being used as antiseptic and germicide. We also have sodium nitrite, which is used for meat preservation additive. And of course, we have here potassium nitrate, which is used in gunpowder, matches, and fireworks. Now let us discuss further about the covalent bond. It is a chemical bond that involves the sharing of electron pairs between the atoms. It occurs between two nonmetal elements. Now, there are two basic kinds of covalent bond. It could either be a nonpolar covalent bond or the polar covalent bond. How are we going to differentiate the two? Now, here is the clue. For nonpolar covalent bond, there is an equal sharing of electrons between the atom. On the other hand, when we speak of the polar covalent bond, there is an unequal sharing of electrons. It either be equal or unequal, so that makes them different. Now I have here the examples of covalent compounds. The first one is the water. So here it is consists of a covalent bond containing hydrogen and oxygen bonding together to make water. In this atomic molecule, two hydrogen atoms share their single electrons with the oxygen atom, which shares its own two electrons in return. Next one is a diamond, which is an example of a giant covalent bond of carbon. A diamond has a giant molecular structure. Each carbon atom is covalently bonded to four other carbon atoms. Electrons are borrowed from these other carbon atoms. Therefore, there is a tremendous amount of energy needed to separate the atoms in a diamond. And the last example that we have is the rubber. It is sticky when warm and brittle when cold. So in 1939, Charles Goodyear accidentally dropped a mixture of sulfur and natural rubber on a hot stove. The mixture heated up and became tough and elastic, forming a vulcanized rubber. Now, let us have some sort of exercises. Our task is to identify whether the given compound falls under the covalent or the ionic bond. So, for example, we have here nitrogen dioxide. Let us first identify the first element, which is nitrogen, and classify it as a metal or nonmetal. In this case, nitrogen is an example of a nonmetal element. On the other hand, the second element is oxygen. It is also an example of a nonmetal element. Combining two nonmetals, we could arrive that this particular compound is an example of covalent bond. Next, how about sodium chloride? Sodium is a metal element. On the other hand, the second element, which is chlorine, is an example of nonmetal element. Therefore, metal plus nonmetal, we could arrive that this is an example of ionic compound. The next one is sulfur dioxide. Sulfur is a nonmetallic element. On the other hand, oxygen, again, is a nonmetal. Nonmetal plus nonmetal, this is an example of covalent bond. Next, how about in a phosphate ion? Phosphorus is a nonmetallic element, whereas oxygen is also a nonmetallic element. Therefore, the type of bond that exists between them is also a covalent bond. Next, magnesium is an example of a metallic element. On the other hand, bromine is a nonmetallic element. Metal plus nonmetal, therefore the bond that exists between them is a ionic bond. And for the last example, which is calcium oxide, calcium is a metallic element, while oxygen is a non-metallic element. Therefore, combining the two, the bond that exists between them is an example of ionic compound. Next, let us now talk about the properties of matter. We can use the properties of matter to differentiate ionic and covalent bond. Let us first start with conductivity. It is the measure of the ease at which an electric charge or heat can pass through a material. Now let us compare the conductivity of ionic and covalent bond. In terms of ionic bond, there is a low conductivity of electric charge or heat. On the other hand, in covalent compounds, there is a very low conductivity in terms of heat and electrical charge. The next property of matter is what we call as the hardness, or the resistance of a material to deformation of an indenture of a specific size and shape under a known load. Now, in terms of ionic compounds are usually hard. On the other hand, covalent compounds are not very hard. They are usually brittle. Next one. We also have the term malleability, the state of being shaped as by hammering or pressing into thin sheets, which are usually observed in foils. Ionic compound and covalent compound are both non-malleable, meaning to say we cannot shape those compounds into thin sheets. On the other hand, in terms of ductility, or the capacity to undergo a change of physical form without breaking, also the two kinds of compounds, the ionic and covalent, falls under non-ductile category, meaning to say they cannot undergo a physical change without breaking. Another property of matter is the term volatility, or the tendency of a substance to evaporate at normal temperature. Ionic has low volatility, meaning to say it does not evaporate easily. On the other hand, when we speak of the covalent compound, it has high volatility. It means to say it evaporates easily. We also have here solubility, or the property referring to the ability for a given substance, the solute, to dissolve in a solvent. Ionic compounds are usually insoluble in water, but they are soluble in organic solvents such as ether, alcohol, benzene, propanone, and other. On the other hand, the covalent compounds are usually soluble in water, but insoluble in organic solvents. Last properties are boiling point and the melting point. Boiling point is the temperature at which a material changes from a liquid to gas. If we are going to compare the boiling point of the ionic and covalent, the ionic compounds have high boiling point. On the other hand, the covalent compounds have low boiling point. In terms of the melting point, or the temperature at which a material changes from a solid to a liquid, so the ionic compounds, they have high melting point, while the covalent compounds, they have low melting point. I have here a table summarizing ionic bonding, melting, and boiling points. These are some of the ionic compounds: the calcium oxide, magnesium chloride, sulfur fluoride, the aluminum oxide, and the sodium chloride. As you can see in the table, it indicates the melting point and the boiling point. A lot of heat energy is needed to break the strong ionic bonds during melting or boiling. Hence, ionic compounds have high melting and boiling points with low volatility. On the other hand, in table 4, we can see the covalent bonding, melting, and boiling points. So here are the example of covalent compound. We have here ethanol, tetrachloromethane, we have ammonia, and methane. Also, it is indicated here about their melting point and the boiling point. A small amount of heat energy is required to overcome the weak intermolecular forces of attraction during melting or boiling. Hence, the covalent compound has low melting and boiling points with high volatility. So, so that ends our video lecture for today. So here is the reference being used for our lesson.